so we are doing simplifying rational expressions. Your accompanying sheet should give you the instructions to simplify a rational expression at the top. We're going to factor our numerator as much as possible. We're going to factor our denominator as much as possible, and then we are going to cancel common factors. So if you look at your example 1, we have 2x plus 4 over 3x plus 6. Remember, when you're factoring, you're first looking for a greatest common factor. If you look on top, your GCF should be 2, which would leave me with an x. I did that again. Would leave me with an x plus 2 if I'll write it right. On bottom, we should have a GCF of 3, which will also leave me with an x plus 2. So we have factored the numerator, factored the denominator. Since these are linear, there's really nothing else you can factor out. So step 3, cancel your common factors. Both of them have an x plus 2. So we can cancel those. And we are left with 2 over 3 for my final answer. Example 2. You've got a 4 minus 2x. And then we've got a 3x minus 6. We don't like that x term being second, so I'm going to move it to the front and make that a negative 2x plus 4. On the bottom, still a 3x minus 6. All right, if I go to factor the top, I know that I want my factor to probably say x plus something or x minus something. So I really don't want a negative at the beginning of my factor, so I'm going to see if I can factor out a negative. So if we do a negative, and then GCF should be a 2, which would then leave me with x minus 2. On the bottom, I can factor out a 3. That would also leave me with an x minus 2. So then step 3, cancel your common factors, x minus 2 should leave me with a negative 2/3. Now if I flip to the back, next one I've got x squared minus x minus 6 over x squared plus 3x plus 2. If you look, we do not have a GCF. We do have a trinomial though, so we can multiply a times c. We need factors of negative 6 that add up to negative 1. So that would be 3 and 2, and we need our 3 to be the negative 1. So I'm going to work this off to the side, x squared minus 3x plus 2x minus 6. GCF of your first two terms is an x, which leaves me with an x minus 3. GCF of your last two terms is a 2, which also leaves me with an x minus 3. So my factors are x plus 2, x minus 3. I'm going to kind of circle that, label that numerator, so I'll remember it later. All right, then I'm going to do the same thing with x squared plus 3x plus 2. So I need factors of 2 that add up to 3. Should be 2 and 1. GCF of the first two terms is an x, leaves me with an x plus 2. I hope if I write right. GCF of the last two terms is a 1, which also leaves me with an x plus 2. So I've got factors of x plus 2 and x plus 1. That's my denominator. We'll put my numerator over my denominator. And then we are looking for common factors. So they both have an x plus 2 in common. So that'll leave me with an x minus 3 over an x plus 1. Example 4, we have a 5x squared minus 15x. On the bottom, we've got an x squared minus 9. All right, on top, look for a GCF. Should have a GCF of 5x. That will leave me with an x minus 3. On the bottom, there is no GCF. You've got a binomial, and you should recognize a perfect square, and a minus sign, so we have a difference of 2 squares, which means my factors would just be x minus 3, x plus 3. So on top and bottom, I have an x minus 3. I can cancel those. Left with 5x on top and an x plus 3 on bottom. And then let's do one more that's not on your paper. So let's look at x minus 3 over x squared minus 6x plus 9. On top, there is no GCF. We've got a linear binomial. There's nothing else we can do. On the bottom, factors of 9 that add up to -6, -3 and -3. Or you could recognize that as a perfect square binomial. Either way, once I factored it out fully, I should have x minus 3 and x minus 3. So it would be really tempting to cancel everything out, but there's only one x minus 3 on top, so I can only cancel out one of the ones on the bottom. So on the bottom, I'm left with an x minus 3. I cannot just leave my answer as x minus 3 though, because there is a top to this fraction. So I need that one placeholder on the top of my fraction.